we will set the torque to have a constant value of 5 inch pound, and we will apply it for a duration of 2 seconds. So in the force property manager, select torque since we are rotating this one, and click the front face of the wheel. Okay, so now let's do it. So look for the force, select torque, so select the face. So make sure that the arrow is pointing counterclockwise. So input the torque. So as been stated, this is 5 pound force inch. So the Z axis will be the torque's direction below the face selection box because we are along the Z axis. Okay, so once we have the setup, check this one, then forget to select motion analysis. All right, so once we have that, let's go to the motion study properties. So click and drag the diamond shape, and from the default 5 seconds, let's go to the desired 2 seconds. So this is the diamond that the module is talking about. So adjust this time. So if we want to make it a bit detailed, so we could adjust this one, zoom in, zoom out. Okay, once we set up the time, let's go to the icon calculate. But first is we have to set the frames per second to 100. Okay, so let's go to the motion study properties. So we will have a more detailed frames per seconds by adding it from 25 to 100. Okay, then select calculate. So from the calculate button, this is the calculate. So we'll be able to run the simulation for the wheel. All right. So notice that if I will play it from start, it is now rotating. Actually, you could make it playback in normal, playback loop. When you say playback loop, playback reciprocate. So it's moving clockwise, counterclockwise. Alright. So playback normal. Actually, you could also make this more slower, as you can see, by selecting the playback speed. Okay. Alright. So next will be, So since this is motion analysis, we should have the value for our motion analysis. So as noted earlier, SolidWorks Motion will provide quantitative analysis results in addition to the qualitative animation of the motion models. So in the result plot, we will select for the angular acceleration Z component and we will select the front face. So we will be able to get the value of 1050 as the angular acceleration. So 1050 degrees per second squared. Okay, so let's go to the result plot. Select category, displacement, angular acceleration, Z component because we are in the Z axis. Select the face and create a plot. So as you can see, we have the same plot as expected. So if we will play this one, you can see the red line from 0 to 2 seconds. It's constant about 1050 degrees per second squared. Alright, so we'll just check if SolidWorks Motion is giving us the right uh, computation if we will go by hand. So we discuss about the mass pound dividing the gravity. Point 1. We will be able where 18 this is 2 degree per second. And computation is giving we will get the version on hand. Verify per second is exceeded the ray displacement, angular velocity, z component on hand. Okay, so at the key tap from 2 seconds to 4 seconds. So the simulation will now last for 4 seconds. So let's move it to the key 4 seconds. But also we could do this. Edit key point time 4 seconds. Okay. A new key will be placed at that location. So the torque will now be applied for 2 seconds, but the simulation will continue for the 4 seconds. Okay, so per module, we need to stop the torque at 2 seconds. So we'll go back here from 0. The torque will be applied at 2 seconds and we'll rotate till 4 seconds. So Let's click cal 0. The torque will be applied at 2 seconds and will rotate till 4 seconds. So let's click calculate. So should be expecting a value of, okay. So what did you see? The angular velocity